Here in this video, we are solving a problem that appeared in NEET 2025 from rotational dynamics. Let's have a look at the question first. A bob of heavy mass suspended the light string of length L. So, here is the length L of the string, right? Bob has given a horizontal velocity of V0. This is what our V0 is. The string gets slack at some point P. This is the point P, making an angle theta to the horizontal. This is angle theta to the horizontal. Ratio of the speed at this point. So at this point, it will have some velocity V. I need to calculate that ratio V with respect to this velocity V0. V by V0 is how much, right? So if I have to calculate that, first of all, I can draw a perpendicular line down. This is the string length L, the same L. Let this height is H. So in that triangle, I can write sin theta equal to H by L. So H is equal to L sin theta. I can use this relation in the future when we need it, right? Further, we can notice this angle is 90 degree, this angle is theta. So this angle is obviously 90 minus theta. Further, this is a mass bob, same mass here. It will have its weight acting in a vertically downward direction. So this mg can be further resolved into components. This is a horizontal component adjacent to this theta. So how much is that component is? Horizontal component is cos component. But be careful, this is the theta. For that it is horizontal. Theta is, as we have just said, 90 minus theta. So mg of cos 90 minus theta, that is mg sin theta. So be careful to understand that towards the center of the circle, there is a force mg sin theta is acting. So once you understand that force is a force acting towards the center, we can say in circular motion the force acting towards the center is nothing but a centripetal force. So you can write mv square by r, who is L here in this case, equal to mg sin theta, like we have proved. This m and m can be cancelled. It can be further said that GL, get this L to that side, is V square by sin theta. I can use this relation also in the future while I am solving the problem. Taking those two things into consideration, consider this point as P, this point as Q. At these 2 points safely we can apply conservation of energy, that total energy at P equal to total energy at Q. While solving that, we can take this point as a reference point. All energies are calculated from there, right? So total energy at the point P, that's at the bottom, is potential energy is 0 because that's my reference point. Kinetic energy is half m V naught square. Total energy at the point P is again sum of two energies, potential energy. Height of that point P with reference to this base is this L and this H sum. So mg of L plus H plus kinetic energy half m V square, assuming that velocity at the point is V. But I have already proved that H is equal to L sin theta. So I can further write half m V naught square equal to mg L plus in the place of H L sin theta plus half m V square. So if I simplify further, of course, first of all, m's can be cancelled. So V naught square by 2 on the LHS side equal to G of, in both these terms L is there, so you can take L as common, GL of 1 plus sin theta plus V square by 2. But we have already found what's the value of the GL for our future reference. So let us substitute that GL value in this equation. So we can further write from equation number 1, I will continue this equation. V0 square by 2 equal to, in the place of GL, I can write this equation, V square by sin theta of this value whatever is there, 1 plus sin theta plus V square by 2. Let us simplify this further. V square by sin theta into 1 is V square by sin theta. Next V square sin theta by sin theta plus V square by 2. This sin theta and this sin theta will cancel. V square by sin theta plus V square by 2 is 3V square by 2. Take V square common, 1 by sin theta plus 3 by 2. Let us simplify this. 2 sin theta, 2 plus 3 sin theta of V square equal to V0 square by 2. These 2 and this 2 also can be cancelled. So I can rewrite V square by V0. I have taken this V0 to that side, get all the other terms of this side to this side. Sin theta by 2 plus 3 sin theta. We need only V by V0. So let's take the square root on both the sides. Sin theta by 2 plus 3 sin theta whole power of the half square root is V by V0. As V square is there in this place also. I have taken square root on both the sides. So V by V0 is sin theta by 2 plus sin theta whole power of half. That's the answer for our problem, right? This is the answer for the problem. So this is how I have to solve the problem. So looks like a little lengthy, but it is a conceptual driven problem. We shall have a kind of conceptual clarity in solving the problem. The most important concept is applying conservation of energy in a system, in a closed system when there is no loss of energy. Total mechanical energy at any point is constant. Of course, this is a simple trigonometric equation. This is a centripetal force equation. Taking these all basic things into consideration, we can solve this problem just like this. Thank you for watching.